Hello again. Tonight we're going to talk about auroras. And the reason why we're going to talk about auroras is not because there have been some energetic solar activity that's caused the auroras to get all the way down into the northern parts of Florida and into Georgia, but also auroras we're finding in other places in the solar system. So, what is an aurora? Think of an aurora as you've got some kind of material, a monatomic element like neon or diatomic like oxygen or O2. Those are excitable, as in you apply energy to them and they will get excited and then produce photons, produce light as a result of that to get rid of their excess energy. And you can do that not only with individual elements, but you can also do it with compounds. Like Helen has these glass tubes that have gas inside of them. And when you apply an electric field to them, they will glow at different wavelengths. So you have like methane has a different color than does carbon dioxide. Different compounds can be excitable. There's other ways you can excite a material to make it produce photons. You can apply photons to it. You can apply magnetic fields to it, or you can directly send electrons and muons into it, or you can have high order particles from radioactive decay, alpha particles, or even protons that will excite materials and make them produce photons. In the case of the natural stuff, you have a star like the sun that has a solar wind of energetic particles, and occasionally it spits out these giant chunks of plasma, coronal mass ejections, and they will also excite materials to produce light. Planets like Jupiter can even get them induced from the moons of Jupiter. So the atmosphere in Jupiter can get excited by the orbital movements basically the twisting of Jupiter's magnetic field by the passing of these moons that causes Jupiter have auroras. It's much easier to excite gaseous materials than it is to first ionize liquids or solids in order to have the gases to be able to excite them. So you need the gases or the gaseous compounds, and you need a source of energy. Now, the particular type of light that comes out of them, depending upon the energy that's applied and the material that gets excited, you get photons in different wavelengths, some of which are visible. Those are the ones like on Earth, they're somewhat visible. They're actually more visible beyond human vision than they are in human vision. You have low energy ones that could be invisible. Those are infrared or even radio. People think about Jupiter having radio emissions. Those are actually emitted from photons that are being energized by magnetic fields. You have the mid-range ones, the popular visible auroras, and then you have the higher energy ones that are invisible, that might be in ultraviolet. I think also, I don't think we have the probes for it at the moment to do that, but I think you can also, if you get an energetic enough environment, you might actually have X-ray or even gamma auroras. If you don't have the instruments, you can't see them because they're not visible to the human eye. And if you have a magnetic field, the gaseous material, once it's energized, will travel along the magnetic field lines and concentrate, increase the flux, the quantity of photons per unit area, which increases the brightness, which makes them easier to see. So on Earth, we think of the auroras, the aurora borealis, the northern lights, the aurora australis, the southern lights. And when they get to be really energized by solar wind or coronal mass ejection from the sun, then they can extend the aurora, visible aurora, down as far as northern Florida. And I guess the southern ones can come up all the way up to the northern side of Australia. We've confirmed the presence of auroras in pretty much all the planets except Mercury and Pluto. Objects where we didn't think there should be auroras, there are auroras. It's just not visual auroras. They're in wavelengths that are not visual. So you have to have the right probes there. So we've confirmed auroras at Venus, obviously Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And we used to think that, Mars can't have an aurora because it doesn't have a giant rotating molten metallic core to produce a magnetic field, and therefore it can't have an aurora. Yes, it can, just not a visual one. Or in the case of Venus, Venus doesn't have a magnetic field that we've detected so far, and yet Venus has auroras, not visible ones. They're deep infrared auroras. The Mars UV auroras, Mars has next to no magnetic field, and yet we can see ultraviolet auroras occurring on Mars. And we found out recently that not only are Jupiter's auroras wideband, they go all the way to infrared, but also they're affected by moons. And in the case of Saturn, we've actually recently found that one of its moons has an aurora absent a magnetic field. So how do you observe an aurora? First, you've got to have the aurora, which means you have to have an excitable material, a gaseous material, either elemental or compound. You need a source of excitation energy, not ionization energy, but excitation energy. What the source is, it doesn't matter. It's agnostic to it. Not only solar wind and coronal mass ejections, but more subtle things can energize auroras. And then you have to have something there to look at it. It'll be very hard to see auroras from Earth itself, from the surface of the Earth, because they're so dim and they may be in wavelengths that don't penetrate the Earth's atmosphere. So it's better to have something out there, something nearby to be able to see the aurora. And I know of recent, the James Webb Space Telescope has spotted auroras on the Jovian planets towards the outside of the solar system. And it's only because it can pull in so much light and it's in infrared that it can detect it. But some of the things that have discovered auroras around various places is Venus Express about Venus, and then to finally confirm the ultraviolet auroras at Mars, it took Mars Express, MAVEN, and the ExoMars Trace Gas Orbiter for people to be convinced that, yeah, it does have auroras. Perseverance has actually, from the surface of Mars, looked up and seen the auroras and recorded them. Galileo reported auroras around the poles of Jupiter. Cassini reported auroras around the poles of Saturn. And Juno, in its movement around Jupiter, has seen auroras about Jupiter. Also, as they flew by Jupiter and Saturn, the Voyagers saw auroras. New Horizons, as it passed the Jovian planets, it got to take pictures of their auroras. I don't think we have any images of Pluto having auroras. You have to have an atmosphere that's not frozen, I guess. And we have deep space telescopes. Hubble can pick up a little bit of infrared and some ultraviolet, and it's high enough in Earth orbit. It's in low Earth orbit, but it's high enough that it can pick it up. And obviously, the James Webb Space Telescope has seen auroras around the planets and moons. We always thought that you needed a strong magnetic field to concentrate the photons in order to make them bright enough to be detected. But apparently our sensor technology has gotten to the point where we can see auroras where we didn't think they were possible, like Venus, no magnetic field, and yet they have auroras in infrared. Mars has a minimal magnetic field, and its auroras are in ultraviolet. But apparently from the surface looking up, you can actually see that the auroras are very dim, but visual. And the moons of Jupiter induce infrared auroras about Jupiter that normally you wouldn't see those, but since we send instruments that can see in infrared, you can see the infrared auroras. And the one that was, I guess, the biggest shocker was Venus not having a magnetic field. We found out it has radio, infrared, visible, and UV auroras. You just have to have the right instruments that have the right sensitivity to spot what you couldn't see before. It's not that all of a sudden it has auroras. It's always had auroras. We just weren't able to see them. Auroras don't necessarily mean something that's visual that you can see glowing. The aurora is just the ionized gas, the excited gas producing photons, and photons come in a wide variety of wavelengths. And so if you have the right instruments with the right sensitivity, you can see auroras or emissions throughout the electromagnetic spectrum. Think that once we have the right instruments in X-ray and gamma, we'll probably find that there are X-ray and gamma auroras as well. Just my opinion. So in summary, auroras, if you have energy and you have material that's gaseous, you can excite the material to make it produce photons, and the photons can be a variety of wavelengths, visible and invisible. And we don't want to sell these shorter wavelengths short. So I think we need to start looking in X and gamma for auroras there as well. We typically think of auroras as being something on the Earth, but auroras, wherever there's the gas and the energy, they'll have auroras of various wavelengths. And so we found auroras on Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, as well as on Ganymede. That was a surprise that a moon that we didn't think much of a magnetic field has an aurora. So it doesn't require a planet-sized body to have an aurora. Smaller things like moons, those can have aurora. You just have to have the right gas and the energy. It doesn't require a molten magnetic core. You don't need a magnetic field apparently to do that. It helps because you're concentrating the density, the flux of the photons to make them brighter. So I think it's another one of those group think changes. In the 1920s, we learned that there are galaxies other than the Milky Way, and we started changing the naming of a lot of things that we thought of as nebulas, like the Great Andromeda Nebula, to identifying it as a galaxy. And now that we've identified that you don't need a magnetic field in order to have an aurora, and auroras can be in visual as well as invisible wavelengths, we're probably going to see a lot more auroras and not limit them to what we used to think of as just visual. And then all the auroras that were spotted on the various things and some of their scientific papers. And then the electromagnetic spectrum. Okay, comments, questions? Who knew there were so many auroras in the solar system?
I had no idea. Has anybody seen an aurora live?
I've seen them from video cameras because there are sensitive video cameras that will do that.
Well, I mean with eyeballs directly.
I have not. I've talked to people that have. Helen's observation of auroras is unique. She got to see auroras in the Earth's atmosphere from the Sophia stratospheric observing 747.
Wow.
You think about it as, okay, where the auroras are taking place from the Earth up to where they are is a distance. From where they are up to the space station is also a distance. It's a slightly shorter distance, but however, if you're at 45,000 feet in a 747, you're quite a bit closer to where the aurora ionization is actually happening than the space station. So she got to see the aurora brighter than even the space station can see it.
Yeah.
So, but I do somewhere in my collection of pictures from her Sophia missions. She actually took her NASA jacket and pulled it over her head and stuffed her face into one of the windows on the airplane in order to close out all the light from all of the interior workings of Sophia so she could see the aurora even darker. Or actually brighter, because it would be darker for her to see it.
Very cool. I would love to see a live one someday.
Well, apparently with the high output of the sun of recent, South Georgia or up in the Jacksonville area, if you go out into the sort of Everglades suburbs of Jacksonville, you can see aurora. It's not as bright as it is up north. It's kind of weird that if you come in from Florida and Georgia, it's dim but visible. And then you get up into the upper latitude parts of the United States, up into the lower part of Canada, and it gets brighter and brighter and brighter. But then you go even further north, and because of the magnetic field lines of the Earth dressing the aurora as this sort of ring arc, it doesn't go all the way to the North Pole. So the aurora you would see at the North Pole would be low to the horizon. Space be big, space be 3D. Okay, any comments or questions? Otherwise, I'll stop recording.